Hey, today we're going to be dealing with modeling with polynomial functions. And really what that means is we're going to be taking different points and we're going to be writing the function given points on a graph. Okay, and we're going to also be determining what degree a function is based upon points. Okay, so write a polynomial function from a set of points. Write polynomial functions using finite differences, which you've done before, you just don't know you've done that yet. At least you've used finite differences. And then we're going to use regression features on our calculator. So, the first piece, write the cubic function of the graph shown. All right, so with that, I want you to write down all the coordinates they give you on that graph. Just write it into your notes there. I'll move that back down so you guys can also see the top for those of you that are. There we go. Hey, so the first thing, we're going to use the x-intercepts. Need your attention back up here. We're going to use the x-intercepts to write a function. This is a cubic. So the x-intercepts, we have an x-intercept of -4, we have an x-intercept of 3, and we have an x-intercept of 1. I want you to take and write that in factored form, what they give you there, based on those zeros. Okay, what do we get here? X plus 4. What do we get here? X minus 1 and then X minus 3. Okay, now the only thing we don't have is our A term out here. That A term right there, we can't just throw in an x. That would be a 0. Okay, that A term is the same A term as if you put it into standard form. Okay, that A term right there, we're going to calculate. The way we're going to calculate is to use this other point. We know an x value and we know a y value, or an f of x value. We can plug those in using this format. Okay, well, f of x, same thing as y, that's -6 here. And that is equal to a times, x is no longer x, it's 0. So we're using a point on the graph, that's not a comma. Okay, we're using a point on the graph to calculate a. Yep, very similar, yeah. You've used this process quite a bit. Okay, so 4 times -1 times -3, we also call that 12. So 12a. So a is -1/2. And then it's as simple as just writing the function. F of x equals -1/2 times x plus 4 times x minus 1 times x minus 3. You are now all done. Yes, it's okay to leave it in that form. Okay, you can leave it in factored form. Dun, 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 dun. Yes, Autumn. Well, we would, right now we're just going to be writing it from given zeros here. Okay? All right. It's good inquisitive thinking though, Autumn. All right. Next piece. I want you to try it for let's just do number 1 here. Go ahead and write a cubic function. Write a cubic function given those coordinates. All right. Hey guys, please note that when I'm putting this in here, you'll note that the x-intercepts are the ones where they give you an integer value for x, a non-zero value. Your y-intercept, or the other point, is right here. So when I'm plugging this in and putting it in factored form, f of x equals a times x plus 4 for that, x minus 2 for that, and x minus 5 there, I then plug in my x and y value. Okay, for 10 and 0, I solve for a, I get 1/4, so f of x is equal to 1/4 times x plus 2 times x minus 2 times x minus 5. Oh, x plus 4 times x minus 2. Excellent, thank you. Okay, questions?
What's next?
Yes, Walsh. All right, Walsh is asking someone else. All right, ladies and gentlemen, go ahead and take a look at page 119 of your student journal. I want you to read those two statements. Talk about what they mean with your groupie. Hey, eyes here. Anyone have any idea what that means?
Nope.
That does what it mean what finite means. So finite also could mean like it ends, not infinite. Oh, is that what he just said? Okay. Hey, use finite differences to determine the degree of the polynomial function. So what this says is what we're going to do here. You'll notice your x is increasing by a constant right here. What's the difference? Here, 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 and here.
That's 21.
28. Okay, here.
3.
I think this is 38. No, 28. Hey, here is? Here? Here. Here.
7, 8, 9.
Relax. Relax. Here.
1.
Okay, so our finite difference, okay, we get to the third level. That means this is a third degree polynomial. If it was the second level, it'd be, hey, stay with me. If it was second level, it'd be quadratic. If it was fourth, it'd be a quartic. Okay, now it says then use technology to find the polynomial function. So the technology they are talking about, the technology we're using anyway, is your calculator. So I need you to put that into your list, please. Put it in your list. Okay? And those of you that are like, I don't know what he's talking about, and I didn't take notes earlier in the year when Mr. McCoy said, hey, take notes on this. Or it's like, man, it's like so hard to get in my backpack and get my notes out. That's tough. If that's you, which I doubt it's too many of you, but there might be one of you out there. Okay. Where do we go to? Second. No, we don't do second. Even though it says list, we don't actually push list. That's weird. It's just stat. Stat, option 1, edit, and we enter our list. First list is going to be x. List 2 will be f of x. Make sure you have the same numbers in each. Okay, once you get there, you hit quit. All right. And you are now going to go to stat, over to calc, and then since it's a third degree, that is a cubic, so we go down to cubic regression, option 6. Enter. And we keep hitting enter until we get to calculate. And it tells us in the cubic polynomial ax cubed plus bx squared plus cx plus d, a is equal to 1.666666667. B is 0.5. C is 0.333333. And D is 0. So in other words, it's f of x equals 1.666666667. is what? It's actually 1/6. X cubed plus 0.5 x squared plus 1/3 x plus nothing. So we'll just get rid of that. No plus. There we've got it. That is our function. Total yay. Hey, now please keep in mind my calculator does not have the diagnostic on. Does anyone have their diagnostic on where it gave you the r squared value or any of those? Yes? So for those of you that want to put your diagnostic on, remember that goes to second catalog or second 0. And then alpha is already on, so just find the letter D. And then get down to diagnostic on and hit enter. And then if you went through that same process of cubic regression, oops, unbelievable, I just keep hitting it, just for fun, it tells you r squared is 1 means it's a perfect match. The closer you are to 1 or -1, the closer that match is. Okay? We know it's a perfect match because of finite differences. Infinitely cool, man. Okay, questions? Woo! Hey, guys, your assignment 120 and 121. I want you to do problem 1, 3, 5, 7, 9, and then why don't we hold off on 10 until tomorrow? Okay? 1, 3, 5, 7, and 9. So that's kind of an odd group of numbers, but that's okay. We'll go with those. Okay? 1, 3, 5, 7, and 9. Ladies and gentlemen, on number 9, you have to use your graphing calculator, or I would use it. Okay? Okay, once you have your function, put that into your y equals menu, and that can help you make predictions. Yeah, man. Yes, Kinsey wants to do it by hand, and that is okay, Kinsey. That's very good.